Now you might be thinking, reading data sheets, really? Do I need to be taught how to read data sheets? And I think so. Reading data sheets and effectively finding information in data sheets is a learned skill, and it's one of the most important skills of a electronics designer of any kind. And these data sheets get huge. Some of the ones we're going to be looking at in this class are well over 500 pages long. Finding useful information and reading these things is really critical. Remember, data sheets are documentation for engineers, written by engineers. And we know that we're not the best writers in the world. So the information is usually there, but it's not usually very clear or presented in the most friendly way, we'll say. So we're going to get a little bit of practice reading data sheets before we launch into some of the major topics of the class. So the whole purpose of data sheets is to provide information to designers, to system designers. And there's a couple of different purposes for this information. As a designer, I might be shopping around to decide what processor or component I want to use in my design, and I want to find information very quickly about the constraints and size and shape and characteristics of a particular device. So some of that information is going to be right up front in the data sheet, and that's where it's going to be. Now, once I've implemented my design or once I've started building it, I want to know more specific things about it. What are its electrical characteristics? What are the logical properties? First, what are the physical characteristics? How big is it? What packages are available? What's the pinout? Then the electrical characteristics. What are the limits and supply requirements? How much voltage does it need? How much current does it draw? What can it process? What are its limitations for driving external sources? That sort of thing. And then the logical characteristics, and this is for things like integrated circuits and stuff like that. What is the timing? What's the protocol? What is it going to do under certain characteristics? For a microprocessor, it might be things like what's the instruction set architecture? What are the registers that are available? What are the peripherals, right? What is it going to do when I send certain signals to it? So let's just dive in and look at some examples. In this particular example, I'm shopping for a RGB LED on DigiKey, and I found this one here. It's pretty cheap. They've got it in stock. And $1.78 for an RGB LED may sound like a lot, but it's actually pretty good. Usually they can be up to $3 or $4 depending on the characteristics. And DigiKey conveniently has a datasheet for me right here, and this is the datasheet for this particular RGB LED. And it already tells me a couple of things. It's very red, blue, and green. It's a T1 3/4, which is the 5mm size of RGB LED. That's a standard size of LED, so it should fit in any standard LED hole that I have. Right off the bat, they give me the electrical or the physical characteristics and also the logical layout. You'll see a couple of things here. So here is how big it is, how long the pins are, how I can identify the differences between them, what the logical pinout is. So here I've got the pin numbers 1, 2, 3, and 4 as here, and then I've got the internal logical structure. So how are these laid out in the thing normally? So 2 is my common cathode, I think, or is it anode? I can't remember. Either way, it's the common ground. So this is the one that this pin 2, this long guy, goes to ground. And then if I want to turn on the red one, I apply voltage to pin 1. Blue is pin 3, green is pin 4. So that's how I know how this thing works. If I'm designing a printed circuit board, I need to know the spacing between the holes so I can make a footprint for how it physically lands on the board. So that's good that they've provided that information here. This is what they recommend for a printed circuit board layout. So that's super handy. The things that you'll see in data sheets like this are stuff like the electrical and optical characteristics for an LED or any optical device. It'll give you stuff like the nanometers, that's the frequency of light that it emits, specific color under certain conditions, and the characteristics of the system that it's looking for. So typical Here we go. The forward voltage, this is what it can handle as an ideal voltage for each of these, is 1.9 for the red, then 3.3 for blue and green. Current nominal should be 20 milliamps, but down here we can see the forward current is different for each of them, and maximum, these are absolute maximum, so we should never exceed these or we end up blowing up the LED. So here we've got 30 milliamps. So the most it can take is 30 milliamps, and it should output a lot, but nominal should be whatever it uses for testing, something like that. So we've got 20 milliamps there, and that's what we should expect from performance out of the device. And there's all kinds of extra optical information about intensity at certain voltages, the this is the spatial distribution of brightness. So it's most bright in front of it, surprise, surprise, but not very bright at far angles off to the side. And we've got one for each of the three colors in here. And there's some packaging information and extra stuff that they've provided in this data sheet. So there's lots of handy information here. Now let's look at a little more complicated device. So this device is a 555 timer. It's one of the most common integrated circuits for really simple things. And if you are in this field for a while, you'll run across it a few times, because this is what, it's an analog chip that does a lot of really handy stuff. And we can often get away with using one of these, which might cost 25 cents or 50 cents a piece, instead of a microcontroller that runs a program. So you should check out these things, look at these things, they're really cool. So let's look at the data sheet for this guy. It has a lot of descriptions. It starts off with a simplified schematic. So this is what the inside of a 555 timer looks like. There's a basic memory component. There's some op amps. There's an inverter. There's a little transistor, some internal resistors, all kinds of stuff like that. This doesn't tell us a whole lot about how it works. If I'm not an electrical engineer, I'm not an electrical engineer. So the rest of the data sheet actually gives us a lot more information. And handily enough, Texas Instruments has provided us with a super fancy little table of contents where I can just hop to where I want to go. So let's go to the pin configuration. So this is the pinout. This particular device comes in a couple of different packages. So we've got a DIP, which is a dual inline package. That's the regular chip that we're familiar with, or a surface mount device package. So this one is a chip that lays down flat on a board and is a little bit more, it's easier to manufacture with, that sort of thing. And we have the different pinouts and descriptions of what the different pins do on this particular chip. So we got a layout here of how these things work. Then we get right into the absolute maximum ratings, the electrical characteristics, what's the supply voltage maximum. There is no minimum apparently, so we could run this off of a single volt and it would be okay. Input voltage, VCC, for these things should be the same as maximum as that one. There's some thermal characteristics, all kinds of good stuff like that. Recommended operating conditions. This is where the rubber meets the road. So here, my supply voltage, minimum and maximum, actually we do have a minimum, so most, it can only operate off of 4.5 volts. Minimum, anything lower than that and it stops working, up to 16 volts. If I have a different version of it, it'll go up to 18. Then we've got some operating temperatures. So these are conditions where if it's operating outside or something like that, we might want to look at these and make sure we're inside of those constraints. Some of the electrical characteristics, how much current we can draw, how much voltage we can draw for all these things, how all this stuff works. This is the basics of it. There's lots of information here. So the best stuff in a data sheet is often the application and implementation. And what they'll do is handily for us, give us a typical schematic of how these things should be hooked up. So depending on your application, this little timer can do a lot of stuff. They'll give you specifics. Now this is not super specific. So I've got input, I've got a specific capacitor, but then I've got just values for RL and RA, but they give us schematics, they give us equations for what those relationships should be. So we can actually see information about the characteristics of what those values should be, and that's a jump start on our design, which is super, super handy. And we get some plots on how these things should work and stuff like that. So the typical application section of a data sheet is often super handy, and we should take advantage of it whenever we can. Now let's look at one of the processors in the family of the one that we're going to be using with the Arduino. This is an Atmega328 processor. Now, I just Googled it. This is often something you can do and find a good data sheet, but you always want to make sure if it's a generic part like the 555 timer, you match the manufacturer, because variances can happen in between manufacturers, even for devices that have the same function. But Microchip is the only one that makes an Atmega, so we're going to look at this one, and here we have the product page for it, and it gives us some basic information, but what I'm looking for is the data sheet. And they give me a couple of options for the data sheet on this particular device. I have a complete data sheet, or I have the summary data sheet. And you can see that there's a big difference in size. So this one is only 400K, and this one is 5 megabytes. So the summary data sheet is often what they use for sales. This is for somebody that is shopping for a processor. They want to find out the most common characteristics. They want to find out what the features are, stuff like that. They give information like the package information, what the pinout configurations are in these nice little diagrams, and this is a great place to look and get an idea if this is for me, if this is for my design, and if the characteristics are important. But if I have one of these things already and I want to know how it works, I'm going to look at the complete data sheet. And the complete data sheet here, you can see this is 442 pages. And what it includes in this data sheet is all kinds of information, how the processor works, what the memory layout is like, system clock and options, all the descriptors and how the registers work for every single one of these different types of peripherals. So we've got all kinds of stuff about how the devices work, how we set the registers, the way it's going to work, stuff like that. The electrical characteristics are often at the end of the data sheet. So here at the very bottom, I've got my electrical characteristics. It tells me my absolute maximum operating voltage, my common DC characteristics, what I can and can't do with these things. So I've got things like my voltages for input and output. I've got my currents for input and output. So the most that I can do with these inputs. Current consumption, maximum current consumption, that's super handy to find out if I'm running at different voltages, what kind of draw should I expect from this processor as it's chunking along. The different speed grades, clock characteristics, external clock drive, system characteristics, all kinds of great information about how these things how this thing is gonna work. And this high level information helps me make a new design for using this processor. Once I've built it and I want to program it, this data sheet will also tell me timing characteristics. It'll tell me what what I need to communicate with it. It'll tell me what my tool chain is. It'll tell me how to program this thing. And this is what we're going to be using as our textbook for basically the rest of the semester. So get familiar with the data sheets for our processors. You can find those in the references folder inside of projects on Blackboard. So go and check those out.